Alright, good afternoon learners. Today you can see in front of me I have some solid geometry that we are going to go through. This should look familiar if you've already dealt with concepts regarding solids and the cutting of the solid itself. I'm guessing the reason you clicked on the video is because you maybe saw the title and you would like to have a bit more insight and detail on this, or maybe some clarity on some concepts. So I'm going to go through this topic. This shouldn't take very long. It's just an introduction into how some of the mechanics for the drawing works. This is specifically catered for grade 11 learners, but you will still benefit from this if you are in grade 10. As a grade 12 learner or a matric, this might still assist you if you haven't paid attention in class at all. It might still benefit you in some way, shape or form. So the first thing that we have here is, let's have a look at the instructions, what you can expect when it comes to solid geometry, and this is how it will be placed every single time. So here at the top left we can see it says expected question given an auxiliary view and front view of a right regular hexagonal pyramid. The figure is being cut by an inclined plane AB. We'll have a look at that in a minute. Draw the given front view, the sectional top view, the sectional left view, the true shape of the cut surface. So this is what they've just told you, that you have a front view, you have a top view, and then you have an inclined plane that cuts the front view here. Right, so this drawing is not given to you. You have to read, you have to basically draw this. Now remember, this is going to be in the form of a pictorial view on the left or right hand side of your page, and then you have to redraw it up to the correct scale. Right, they'll give you all the measurements for this specific drawing. So the first thing we see here, the projection. Step 1, question conditions has to be met. That means you read through your question like we've just done, then you have a look and see, you have to draw the front view, the sectional view, sectional left, and the true shape. So if they ask you for a sectional left, we know this is supposed to be first angle orthographic projection. So that means the left view is going to go onto the right hand side. If you started this drawing on the right side of your page, it automatically means you will not have space for this. So then you realize 30 minutes into your drawing you messed up and you have to start again. So we have to map out the drawing. Know what is expected from you, right? Instructions. Map out your drawing, the thing I just discussed. That's very important. Draw in construction when planning and then label all details. So this is considered to be a copy piece. The X, Y, and X1 axis that you have here is supposed to be a natural thing at this point. Typically we don't, if you leave a space between the XY and your front view, that's perfectly fine. Otherwise this should be fine as well. It doesn't matter how it's drawn, it just has to be exactly the same as the copy piece that they give you. Step 2. Alright, step 2 is projecting the cutting plane AB onto your top and left view. So AB, that's now this line, A, B, C. This is your inclined plane that you now have to project onto your top view and onto your left view. So typically what's going to happen, you might do your front view first, or your top view first, sorry, and then once you are done, draw the 45 and project it to start with your left view. You can choose how you would like to go about doing this. Label the inclined plane for more clarity. Again, this is my 2 cents. You really don't have to label anything that you have here. Nothing has to be labeled on your page, but it really does assist you and it does help. So please try it. Use the 45-degree angle to connect the top and the left view. This is what they mean. There's the 45. So when you draw point 3 onto the 45 and straight up, it should connect onto exactly the same point. Okay, so the first thing is we can see the inclined plane has been, you can bring those points directly down because it cuts on the base and on the letter there. It cuts exactly on the base here as well. Point B, if you project that point straight down to the top, there's no way for you to determine where it's supposed to be. So this point we are going to consider as a turning point, which means we can't just project it down. We need to get it to a different location and then maybe we can project it down to where it should be. If you don't have your left view drawn already, where you can project this onto your left view, down to the 45, and over onto your top view. You can project point B onto a similar line, or a reference point, I'd like to say. That's a line that you already have. So you already have point 4 and point 5 that goes to the top. You have that line. So on your front view, it would be this line here. So you take point B directly horizontal onto that point. Then you bring it straight down until it connects onto that line. Exactly that same point. You take your compass on the middle of T onto that point, and then you draw a curve, an arc that goes up to the vertical point there. And that is where your point B is supposed to go. You can see it lines up perfectly with 45 all the way up to point B. So that means it's done 100% accurate. Point C comes down, it connects exactly where it should, and then vice versa. Point A that you have here, if you take this point onto your left, there's no way for you to calculate where it's supposed to go. So that's also going to be considered as a turning point, where it has to go onto the 45 and then straight up to where it's supposed to be on the base. So having a look at step 3. Alright, draw the cut surface, by connecting the dots. Only focus on connecting the dots and showing the section. So A, B, C, all the way around, you start by drawing that in A quality immediately, because you are indicating the section to whoever has to mark your stuff, or to yourself. When the base gets cut, the shape changes. So in this case, that is considered to be the base. The shape, hexagon, pentagon, octagon, square, triangle, it doesn't matter what the base shape is when it gets cut. So this, it just nips on the side, unless if it cuts on the flat side. So here it cuts on the flat side, or if it cuts on the corner itself, it means that is not going to change. But if this inclined plane went through here, right, then it means this part would have been removed from your drawing. So if it cuts through the base, then it means the shape that you have here changes. So that's something to just take note of. Step 4. Hatch the cut surface and add the hidden detail. Alright, we'll be dealing with that now. Use a B quality line type to hatch the solid. Darken the outline of the visible parts of the remaining solid. So here you can see the difference between step 3 and 4. Here we haven't outlined anything yet. So as soon as you have the cutting plane, you can go ahead and draw in what's supposed to be in A quality, and then you hatch in B quality as well. And usually the instruction will say add all hidden detail, and that is where you look at what's going to be at the back of the drawing, and you add those as well. Having a look at step 5. This is now where we get to the true shape. Really is super easy. Let's have a look. Project the true shape by measuring the inclined plane X and Y. This is the inclined plane X and Y. So the distance from A to C, you measure this directly with a compass, a ruler. You can grab a piece of paper like this. I typically like to do this. We have a paper that you line up with the inclined plane, and you label it A, B, C. Okay, so you have those points there, and then you can go ahead and place it down. See, it lines perfectly, it's perfectly in line with those points. So you can go ahead and say that's A, B, and C. So this is what I tend to do. It's much easier, and it alleviates any measurement problems that you can have. Project the cut surface on the top view onto the respective letters of the inclined plane that was placed. So if you have enough space on your drawing, let's say you were drawing on an A3 page and you have more than enough space on the right hand side, you can extend your XY axis here and draw the true shape here. That means you are still going to leave your 45-degree angle exactly in place where it's supposed to be. But if not, and you see now I have a bit of a problem with space, then you erase everything here. You put down your inclined plane, so there it's A, B, C. You project those points down, and then you project the cutting surface on the top view onto those points. So A goes onto A, B goes onto B, C goes onto C, and so forth up until you have the shape. Step 6. Connect the dots of the true shape, hatch and label. So now you go ahead, you should have all the points that you need. You connect them, you draw a little line and you write there in capital letters true shape, you hatch the true shape, and that is it. That's going to be your drawing done and dusted. Nothing to worry about. And this is the absolute introduction and basics to solid geometry. Alright, so remember, if you don't start now, that's why the whole ordeal or the name for the channel came from, then when? Because every Monday is a new Monday, and every Monday you're going to start and you never start. So start now.